Welcome guys to study the movement of a charge in electric field. Before starting this topic, I have to remember you that electric field can be expressed as a vector, so it has x component and y component. Consider a charge moving between two parallel plates of opposite charges as shown in the figure. The x component of the electric field is 0 due to symmetry, so electric field has only y component. So the electrostatic force at the charge is F equal to Q times E. Also, we can realize that this particle is moving downward with an acceleration in y direction only. According to Newton's second law, the net force will cause the charge to accelerate with an acceleration AY. So we can obtain the acceleration formula by dividing F over the mass of the particle. Suppose now the particle is at rest, V0 equal to 0, when it is first released from the positive plate. The final speed of the particle as it strikes the negative plate is Vy equal square root of 2 times absolute Ay times y, where y is the distance between the two plates. Finally, the kinetic energy of the particle when it strikes the plate is half times mass times Vy. In this example, you are required to find the acceleration, then the speed and the kinetic energy. Finally, you are required to find the time needed to reach the positive plate. This is the answer, guys. You can check it. This is the end of this video, guys. I hope that you enjoyed the video. Don't forget to like this video, subscribe the channel, and have a comment if you have a question. See you in the next video.